Okay, we've talked about the shape of the distribution. Now I want to talk about the center and the spread. Now, in the shape of the distribution, we did talk about the median, and that's also a measure of center. The median is the middle value. Another measure of center is the mean. The mean is the arithmetic average of all of the data points. And that's what this symbol means. It means this capital sigma means add up all the individual data points and then divide by the total number of data points that you have. We use X with a bar over it or Y with a bar over it, whatever symbol we're using for our data points, to represent a sample mean. So X with a bar over it is our sample mean. So for example, I want to calculate the volume in ounces of the Coke in 5 different cans. So to get that mean, I am going to say my mean is add up all the data points and then divide by the total number of data points that I have, which is 5. So if I add up all of those values, it adds to 61.1, and that works out to be 12.22. So our mean for this data set is 12.22. The standard deviation is a measure of variation about the mean. So what we do to calculate the standard deviation, and by the way, we use a lowercase s as our symbol for standard deviation. I take my data point and subtract the mean from it, then square that. Add up all those values and then divide by 1 less than the number of data points I have. Then take the square root of the whole thing. Now, before I take the square root, it's called the variance, and we use s squared to symbolize the variance. Let's do the same. Let's do our standard deviation for the soda cans we just found. So, to get the standard deviation, I'm first going to get the variance, s squared. So what I do is I take 12.3 and subtract the mean of 12.22, and then I'm going to square it. 12.1, subtract the mean, and square it. And keep going with each of my data values here, all the way until we get to this last one, 12.2 minus the mean. And then divide by the number of data points I have is 5 minus 1. So I'm going to divide by 4. So once I get this calculation, it's the variance. If I take the square root of it, s is going to be the square root of this result above. Let's use technology to help us, but we're going to do even better than plugging in what we had. I'm going to plug those data values into list 1 in my calculator. Once I have them in list 1 in my calculator, now I'm going to go to Stat, Calc, and that one variable statistics again. I want to do it on list 1. And here I see that mean that we calculated, 12.22. My variance is the square of this number right here. This is my standard deviation, 0.084. So that's the standard deviation. So I actually have to square that, 0.08366, I think it was, and then square it to get the variance, and that would be my variance for this sample. Now, the standard deviation tells me more than the interquartile range because the standard deviation takes into account how far each data point is from the mean, whereas the IQR only tells me what the spread of the middle 50% of the data is, the data in between Q1 and Q3. The first quartile and the third quartile would be the middle 50% of the data. For a skewed distribution, We use the median and the interquartile range to describe that data. A mean and the standard deviation are really only good descriptors of a symmetric distribution.